Hi, my name is Afreen Bhumgara, and today I'm going to talk about my project pitch for CS 497 Sports Tech and Learning. So, the topic that I want to speak about today relates to data science, sports, and music. And I want to discuss how Spotify or music can help one run better or perform better in sports. So, my mission is assessing the impact of music on running in sports and developing a recommender system or a tool to enhance performance. And my objectives and goals are using music to monitor and improve the overall health status, to enhance, improve, and boost performance focus at sensitive times for athletes, and to get the most of sports training using machine learning, computer science, and sports analytics. And my basis, target audience, and modality for this research project is listed here. So, according to my research, music results in an increased peak anaerobic power, which indicates an enhanced ability to perform powerful energy consuming actions. And music has also shown in research to support recovery after physical exertion. There are a lot of benefits of music, and I want to speak about how we can use machine learning models to create a recommender system that can further enhance our performance, especially when performing running activities or other sports activities. And my target audiences are the general educational and scientific audiences, and anyone with an interest in sports, biology, the human body, technology, analytics, computer science, and artificial intelligence. And the modality and equipment of this project is the analysis of music records using a popular streaming app such as Spotify, collecting physical data recorded during the running exercises via a sports watch, and a focus on the building blocks behind this solution workflow. And so my experimental setup or the different phases, how I intend to go about this is data collection and processing. So this is the phase where I'll actually be using Spotify's API as well as another API to collect the running data. And then I'll do the hypothesis testing to check whether music does actually lead to an increased performance in running and other sports related activities. I'll then use some machine learning classifiers and frameworks and perform feature engineering as well as validation schema. And finally, I'll build the recommender tool or the recommender system that will perform feature analysis as well as personalized song recommendations depending on the type of activity or sports exercise that is being performed, as well as the personalized choices of the athlete or the person. So for the data collection and processing, I intend to collect almost 50 different exercise records using Polar. So for each of the running exercises, I will be using a Polar device to record the running physical variables. And for each exercise, the sports will collect the GPS data, the heart rate sensor data, the accelerator data, accelerometer data, and the running cadence. And after we sync the device with the Polar app, we can collect all and use all of this recorded data. And along with that, for the automated data collection, I will be using the Polar API. So with that, I will be able to exploit the Python public wrapper around the API. So what this API does is it uses a transaction schema to automatically fetch the recorded data. It takes a look at the implications on the data that is available and then uses best practices to retrieve exercises that are suitable. At the same time, I will also collect and synchronize the data of the music stream during the exercise if any music is being played. And for that, I'll be using the Spotify app. So the music will be played while running. That will be retrieved in an automated way using the official Spotify API and the Python wrapper Spotify. And so these are the different steps that I'll be going through for my hypothesis testing and machine learning framework phases, as well as while building the recommender system. So I intend to train a set of regressor algorithms that will predict the running performance in each time interval of the exercise. I will then check if the addition of music features related to the exercise, like if additionally adding the music during the exercise improves the predictive power of these algorithms. And for that, I'll use the coefficient of determination to assess the dependence between the running performance and the music predictor features. Then I'll actually assess the impact of the music during running, and I'll take advantage of the regressors to build a solution that selects a song that can maximize the performance of the athlete or the user during that particular exercise. And finally, I will build the recommender system that will stream and play songs to optimize the performance during the exercise. So beyond the Polar App API, the processing of done will be the processing of the data will be done using pandas, and I will be using some different functions to determine the performance of the user during that time. And this is my testing plan. So this is the timeline in seconds, as well as the different phases, which is the warm-up phase, the observation phase, as well as the running phases. So the warm-up phase includes running at 9 km per hour. The observation phase includes setting the testing speed, as well as taking different features and factors that we can collect from the Polar device. And the running phase also includes different types of conditions, whether we include the music during that phase or whether we don't. So this is the evolution of different testing phases and timeline in seconds. And for the recommended tool, I intend to have the input and prediction. So for that, I will be taking in the ML solution, which takes the input data recorded in an exercise, and the regression algorithm predicts the performance in the next time interval. The impact quantification quantifies the impact that we are given related to the input features that we use for the music stream. It follows a validation schema and it maximizes the predicted gap efficiency, which is another measure that can be used to check for performance during running. And these are the different technicalities that I will be implementing. So the neural networks will be Keras, and I will implement nested cross validation schemas. And the system recommends a song that leads to the highest gap efficiency prediction so that the user can have the highest running performance. It maximizes the predicted running performance, and it aims to maximize the overall performance during running and other sports activities. So the recommendations are tailored to the specific runner, exercise, heart rate, cadence, elevation gain, and other such features that are considered. And this is what I intend that the tool will look like. So this is an example of the how the Spotify recommendation system will look in Linux. So this is like for a specific player, depending on the exercise they're doing, depending on their various heart rate factors, their GPS, their cadence, their accelerometer, and all other features, as well as their personalized choices. And this is how the tool will be created so that different songs can be suggested to improve the overall performance during the activity. And this is what I intend that the expected results should look like. So here we have a graph that shows the gap efficiency along the y-axis and the exercise time in seconds along the x-axis. So the gap efficiency for a progression run is in orange. The prediction of the best machine learning model is in brown, and the prediction with the recommender system is in dark green. So our recommender system performs very accurately in predicting a song that can lead to the best performance for that given user. And this is what I'm expecting to achieve. So this is a division of my milestones, how I intend to research and gather data at the end of each week. And in the first week, I will research and gather data about the impact of music, sports performance, and its implications, consume content, as well as collect data using the Polar Link API and the Spotify APIs, and design the flow of the experiment testing and setup. In week 8, I intend to do the background research and literature review and understand the relevance and applicability of these machine learning algorithms, as well as see how the intersections of this field has transformed problems, real life problems for people. And at the end of week 9, I intend to continue with my research as well as understand the ethical and moral implications and constraints of the field, as well as build the Spotify recommender system for optimal sports performance, especially in regards to running performances. And at the end of week 10, I intend to connect with many more people working at the crossroads of AI, sports, and music, and understand the applicability and future works, and well as the constraints related to this field. So, thank you so